Welcome to our final section on microorganisms, where we're going to talk about organic matter. And this is a picture from Bowie's Creek golf course, and I'm going to talk about the difference between Pinehurst and Bowie's Creek in the soils. And one of the main things, well, clay is a big part of it, but also organic matter is a part of that. So you can see that the plants are quite different here than they are in Pinehurst. So organic matter. Here's Mr. Hoffman, graduate of Sand Hills Community College Landscape Gardening Program, owns Hoffman Nurseries, excellent source for organic and native plants. And you can see he's got a big stockpile of organic matter, and he looks at that as gold. Some examples of organic matter. The number one in the golf course industry, we've got peat moss. We're going to talk about that later in about 3 or 4 slides. Grass clippings, we're going to have about 3 or 4 slides on those. Any leaf matter that falls from the trees. Sometimes we don't think about it, but stumps in trees are examples of organic matter. They are more difficult for microorganisms to decompose, but still are decomposed. Roots, again, resistant to decomposition because they have to be down in the soil with the microorganisms all the time. All the dead microorganisms, bacteria, there's a huge number of bacteria that are constantly dying and being turned over in the soil, and we're going to talk about that quite a bit. And then macroorganisms. So when the mafia goes out there and buries Jimmy Hoffa's festering flesh in the soil, that is also available and going to be remineralized so that plants can use the nutrients from a human or any other animal that dies and gets into the soil. So here we've got a little definition for you. The parts of the soil that include animals and plant remains. So dead, dying, and decaying plant or human material is organic matter. Pretty much including carbon. So sugar, carbohydrates, starches, cellulose, very long fibers of sugar that you would be familiar with from cellophane or rayon, and then lignin or wood or corn, so very much harder stuff to decompose, and we'll talk about that as we move forward and talk about lignin and the decomposition process. Humus is something that people are going to talk about, or humic acid. In lab I'll show you what that is, but that is pretty much the material that is decomposed the slowest or left around. So a lot of the amino acids can be slammed together with peptide bonds and form this big hunkin molecule of carbon that's more difficult for microorganisms to decompose because it doesn't have a lot of ends. Where sugar's wide open, it's got a lot of ends, it burns high, it's easy to get energy from. Humus is much more difficult to get energy from, so it's a much slower burning fuel. You would think about dried leaves like sugar. If you lit that, that would burn instantly, but a great big log might have a lot of energy in it, but it's going to be difficult to light. You might not light it on its first try. Sometimes we'll talk about the carbon to nitrogen ratio, and we can use that to our advantage. If we put down something that has a lot of nitrogen in it, its C to N ratio would be low, something like soil humus or garden soil. But if we put down something with very low nitrogen in it and very high carbon, something like sawdust, we may, for a short period of time, decrease the amount of nitrogen in a soil or in a lake. One thing that has a very low C to N, very high C to N ratio, very low nitrogen is wheat straw. If we put a bale of wheat straw floated in the pond, the microorganisms will start decomposing that wheat straw, and those microorganisms need nitrogen. So microorganisms use nitrogen just like plants. If there's low nitrogen, the microorganisms will take up that nitrogen and what we call immobilize it. So when it's immobilized, it's not available in the pond, which is a good thing, or not available in the soil might be a bad thing, but later other micronutrients will come in and decompose those micronutrients and what we call mineralize or release those nutrients to the plants and the other micronutrients. So there's a constant battle going on for these nutrients. The microorganisms are very efficient at taking carbon, also efficient at taking nitrogen, but usually carbon is the thing that they're most interested in. And when they take up that carbon, particularly off of amino acids, they're going to leave nitrogen behind that is available for plants. Here's a slide just reiterating that point. Microorganisms immobilize nitrogen, phosphorus, and sulfur. So if you're doing a compost pile of stuff with low nitrogen like sawdust or leaves, home lawn leaves, leaf litter, you can add a little bit of nitrogen. So we recommend in the fall in northern climates where you have a lot of leaves, put some nitrogen out on those leaves, chop them up, and then you'll get many nutrients mineralized by the microorganisms throughout the fall and winter, and then in the spring you'll be much better off. So a slower release, that fertilizer will be taken up by the microorganism and then released slowly over time throughout the next summer. So good way to add nitrogen to the system without getting any sort of burn. So here is a graphic representation of the respiration and the oxidation reduction. So using oxygen to make energy from sugar. And as you recall, oh, we don't have that picture there, but our photosynthesis equation from last time, the inverse of that is the respiration. So in the soil, organic matter with oxygen. Oxygen is very important as the terminal electron acceptor because CO2 is the byproduct. Microorganisms get energy, they release water, and also what's left is the humus material or humic material that we're going to talk about. Again, this happens at another step. That humic material can have oxygen added to it, and the microorganisms, all this is microorganisms, or this represents that microorganism cycle, and it is a cycle. Photosynthesis is going to take the CO2, as you recall, and make sugar out of it. Microorganisms are going to take the sugar, organic matter, and make energy from that. So sugar, C6H12O6 plus oxygen can be respired. Energy can be taken from that by microorganisms, macroorganisms, and plants. So all living things respire. Only plants photosynthesize. So here's a little summary. 6 things that affect organic matter buildup in the soil. And the plants. Number 1, a prairie versus a forest. I'm going to show you a picture of grass grown hydroponically. And without a doubt, prairies, grasslands, unmowed, are putting quite a bit of organic matter into a soil system. Cropping, if you come into a prairie and plow that, which would be cultivation, down here, number 6, we're going to talk about in a second. But when you crop something, you could, most likely, are going to decrease the total nitrogen in that system. You're going to add some nitrogen. There might be some nitrogen loss. But in a very arid soil, like in Jerusalem, they can take the desert and grow tomatoes there. Obviously, they're adding nitrogen to the system. pH, very high pHs, very low pHs are going to limit the amount of bacterial decomposition. They may limit the amount of plants that put up. So pH can go in either way. at extremes, either helping more organic matter be put down or decreasing that, depending on the pH and the extremity of the high, whether high or low. Temperature. The cooler an area is, the less fast the microorganisms will do decomposition, and the more organic matter will be built up. That's one of the major factors between north and south. There's a lot less good decomposing time in the north, where in Raleigh there's a lot of good decomposing time. So there's a lot less organic matter in the south than there is in the north. Soil texture affects the amount of oxygen that the microorganisms have available to decompose. So sands allowing more oxygen in are going to increase the metabolic process of the decomposition process of the bacteria, lowering the total amount of organic matter. Usually in a sandy soil, it's composed to a more fine textured soil. Moisture, both in the soil and in the air, that's going to be increasing until it decreases, and we talked about getting anaerobic. So it can limit decomposition at the extremes if we limit the oxygen that gets into the soil. But generally, the more soil moisture, the more organic matter is going to be put down, because the better the plants are going to grow. And then aeration. Aerification is going to decrease organic matter. So when you aerify your putting greens, you're helping get rid of that thatch layer, that layer of organic matter that's bad for the soil, by letting oxygen in there and increasing the metabolic process of decomposition. So cultivation of croplands or cultivation of a meadow is going to do the same thing. So here is a picture from my PhD work at NC State, and you can see grass plants, the bigger they are, the less mowed, the more roots they're putting down, the deeper roots, and this is just more organic matter, more biomass. So all this, both roots, shoots, when the top dies, it will be put down into the soil as organic matter. All the roots are already there as organic matter. So grasslands are putting down incredibly large numbers of biomass that becomes organic matter in the soil. And that's going on in the forest also. So don't say all the leaves that fall down, but trees are pretty efficient at keeping that nitrogen and biomass up in the sky, where grasslands are putting it right down into the soil. So here we go. So a second look at that. That was an important point, and this is taken from a talk Dr. Frank Rossi did, where I just took a picture of his slide. But he talked about factors influence the rate of decomposition by soil microbes. So temperature, moisture, soil pH, aeration, cultivation, and the microenvironment in the thatch. So soil microbial activity is slowed by low temperature, lack of moisture, insufficient soil, and an extremely acid soil. So these are things, if you have these conditions, you will have thatch problems on your putting green. So these relate straight to golf course maintenance, and you need to understand these principles for the final exam, but also to be a successful golf course superintendent. So here's another representation of these points. As we move from south to north, it's cooler, and we're going to build more organic matter. As we move from left to right across the country, we have more rainfall, which is going to be more organic matter. And if you look at satellite photos from Google Earth, you'll see it's much greener in the northeast than it is in the southwest. And that's part of the reason why is the rate of organic matter decomposition. So we've got a sandy soil on our golf course. We often do. What can we do to help it? If we add organic matter to that, which we often do, peat moss in the greens, almost all the USGA greens, most any greens built anywhere have peat moss in them. We're going to increase the water holding capacity, increase the nutrient holding capacity, release some mild acids that can help make nutrients available, and also help make soil aggregation. So 4 big pluses for adding organic matter to sandy soils. To clay soils, turns out we can also improve the tilth. We may lose a little bit of nutrients, which is okay because they'll be re-released later when they're mineralized. But this tilth is very, very important. Allowing a soil to be looser, allowing more oxygen to get in there, allowing plant roots to get through. So useful on both ends, probably more so in a sandy soil, but also in a clay soil, the addition of organic matter. I'm going to show you some ways here. The next slide's how to increase the organic matter in your soils. Recycle clippings. Without a doubt, whenever possible, always try to return the clippings to the soil. It saves labor, it saves time. Even if you're removing them only for playability issues or for weed control, if you're trying to control POA, you can use these clippings somewhere else, either in a compost pile or in dead, dying bare spots to improve the amount of organic matter. And this is, we can see this particularly in the clay soils in the Piedmont area. Returning the clippings dramatically increases the quality of turfgrass. We can use manure, we can use yard waste, we can use mulch. Organic matter's a form of fertilizer. It's probably a better form of fertilizer than some of the natural fertilizers because it's slower released, and you don't have that burn potential that you sometimes get from a really high salt nitrogen source. So here we go. Here's our little cartoon. Fred left Sue holding the bag and mowed without returning the clips. So just faster. I would rather you mow twice or 3 times more and not pick up the clippings than pick up the clippings. Picking up the clippings is just throwing fertilizer away, and we've proved that over and over again. So to summarize, the types of peat moss, we've got sphagnum peat moss, a little bit more acidic, hepnum moss, a little less acidic, and then reed sedge, a little more decomposed because reeds and sedges have more lignin in them. And one of the reasons we can harvest these from a peat bog is that this lack of oxygen in the bog dramatically holds down decomposition. However, sometimes when we open up the bog to drain it, we can have rapid sinking of the peat moss, and that can go down. So peat moss can hold 20 times its weight in water. It has a low bulk density, sometimes even below water, and they can float. It's high in nitrogen usually, lots of amino acids in there, so the mineralization of the peat moss releases nutrients that the plant can use. It's low in phosphorus and potassium usually, but if we add it, there are cation exchange capacity sites that will hold those nutrients. Once they get dried out, wind can blow it away because it's light, it has a low bulk density, and it can even burn. So peat bogs have been known to catch on fire, and sometimes in Ireland, where they don't have many trees, they have used peat as fuel. So it does burn slowly. As I talked about, it's not like leaves, and just like a great big log, it will burn for a long period of time. This slide might not be headlined as well as it should be. Shouldn't be dangerous, but things to look out for. When you have 20 to 30% organic matter, you pretty much have a marsh or a bog. It's going to be squishy. It has a lot of aluminum and some heavy metals in it, and if we grow sod on it, which makes some sense from a distribution standpoint because the bulk density being lower makes the weight lower, so when you're paying shipping costs by weight, you have a much lighter material. Unfortunately, if you take sod grown on a peat bog, which all the sod in Michigan is, and you lay it on a finer textured soil, the roots may never root down. And I went to a yard in Michigan that had been in for 10 years, and it had a grub problem. And what happens with, we have this different texture, the sods lay down, we've got the organic matter, and the roots never go through. So this grub problem, some skunks had come and tried to get the grubs, and they were able to just completely lift the lawn right up. There was no rooting at all. So a soil layer problem, as we talked about in earlier sections of this course, does cause moisture problems. So the moisture is not going to go through this layer. It's going to bog up. So we're going to have a mushy layer with no roots going through that soil texture boundary layer. So you need to be aware of that and look at your sod and maybe get wash sod or do something to incorporate those soils and allow the plant's roots and water to get through to the other level. So back to our more clayey soil, higher organic matter content, you can see much different than our more sandy soil, probably a lighter color, looser, faster draining soil in the Pinehurst. So that's our last section for this course. We'll have one more section, which is review, but please go over these topics. They're very important for you on the final exam and also to be a successful golf course superintendent.